So we're on the model, your combined 1D, 2D model, and you bring it back in, and what is it you can look at? So this is an example of the kinds of things that you can see. And there's a lot going on. You got the 2D model outputs, the depths going overland. Up in the kind of the top right corner, that's a discharge plot. And there's kind of right in the center, bottom center, that polygon's kind of telling us where those plots are taking place. So that's both the cross-section view that we see on the lower right and the discharge in the upper right, all come from kind of that piece, right? So we can plot time series and section plots through the 1D at the same time we're viewing the overland from the 2D.
It's a great day. You've come to another brilliant water webinar free from the Australian Water School. Just goes to show, best things in life are free. Welcome to this Improving Swim Modelling with GIS Tools. And look at the picture on your screen right now. 800 plus people from over 78 countries. Thanks so much for joining us, everyone. Rusty, Matthew, Pavlina, Phil and Chris, so appreciate you being with us today. Tell us just a sentence or two who you are, where you're from, and that'll get us cracking, I reckon. Kick off, maybe Rusty, kick off.
Yeah, I'm Rusty Jones. I work at TUFLOW, and I live in Des Moines, Iowa. And always loved water. I actually grew up, my dad was a contractor. He made irrigation ditches, so we were learning how to flood things on purpose. So that's kind of how I got my start.
What a great background. Matthew, yourself?
Yeah, Matt Anderson. I'm coming from Jacksonville, Florida. I work with Inundar, which is the TUFLOW North American distributor. I also, during the day, work for Gauge Engineering as the hydraulic modeling lead. While my father was not into drainage ditches, I enjoyed the sandbox and built cities in sand and flooded them. So
that all works. Drainage ditches, sandboxes. That's pretty good. Pavlina, yourself?
I work for the TUFLOW team. I'm based in Brisbane, Australia, and I really enjoy working with the hydraulic models and with my great colleagues from the team.
Fantastic. Thank you, Pavlina. And Chris, yourself?
I won't steal much time from Rusty and Matt. From the TUFLOW team, just like Pavlina, just ticked over 20 years.
Okay, completely over to you, Matthew. Ready to roll when you are.
Thank you, everybody, for joining today's TUFLOW webinar with the Australian Water School. As Trevor did, I'm Matt Anderson. I'll go ahead and get us kicked off. We'll be talking about improving swim modeling with GIS tools. Just a quick disclaimer, some of the graphics are based on models that have been provided by others, and the use of these graphics does not imply that endorsement by those who did provide them. So today's webinar, we're going to talk a bit about improving swim modeling with GIS tools. So I'm going to cover primarily some EPA swim background, some history. I'll personalize it a little bit. You get to know me a little bit better. And then Rusty is going to get into some of the new TUFLOW SWMM GIS tools that are available, and how you can leverage those tools with TUFLOW SWMM models. So 3 parts, pretty simple, but pretty powerful in what the tools are, and how we can execute on those. So improving swim modeling with GIS tools. Let's take it back a little bit. EPA swim background and history. This dates me a bit, but 1969. I wasn't around. I could only read this in the history books. But 1969, in the U.S., the Cayuga River in Ohio caught fire. Right, a lot of really bad stuff happened. Water quality was kind of top of mind. The internet, which is kind of what we're doing right now, that also was born in 1969. That's one of the initial interface processors. Took a little longer for it to pop on the scenes. But one of the popular shows was the Brady Bunch. And my wife's a big fan of the Brady Bunch, and the main character, Mike Brady, was an architect who sat there drawing by hand on tables very similar to that. From the history of CAD, this is the way things were done back then. The Beatles released Abbey Road and things like that. Well, the Federal Water Pollution Control Administration, which kind of is a mouthful of a federal agency, it doesn't exist anymore. It got merged with a couple other agencies a couple of years later, but it approved 3 grants to begin the development that the Metcalf and Eddy engineering firm back in '69 and the University of Florida, to start looking at combined sewer overflows and stormwater modeling. So it took a little while, right? The grant was approved in '69. So in the fall of '69, when a couple of students showed up at the University of Florida, their task was to begin to build what ultimately comes to become EPA SWMM. And EPA SWMM back then was really 4 programs. They're called blocks. The first program, runoff, right? Second, transport. Third, storage and treatment. The fourth, receiving, right? And all of these elements, they all kind of talk to one another, but they all ultimately allowed planners and engineers to understand the frequency of combined sewer overflow, as well as the volume and the impact to cities. I think San Francisco was one of the first cities to begin to do this. This was all done on a mainframe, right? Well, just like any application in computers today, right? There's always something we can do better, right? So a number of years later, 1975, SWMM 2 came out, and they ultimately took transport and extended it. I love the naming. So extended transport became XTran. Again, still on the mainframe. And my understanding is when NASA wasn't shooting off rockets, they were actually using those NASA mainframes to run SWMM models. A lot has changed, right? So by 1981, SWMM 3 comes around, right? Again, adding more functionality, open water channels, or open channels, water quality were some of the 2 highlights there. 1988, kind of a interesting break, but that is ultimately when SWMM 4 came around. That was SWMM no longer on the mainframe, but written to run on the personal computer, the PC. We also added groundwater and RTK. Ultimately, that's kind of as I began my engineering schooling, right? I started to learn on SWMM 4. Very interesting back then. Ultimately, in 2004, when I was in private practice, SWMM 5 came around, and that had an EPA. EPA actually put a wrapper around the SWMM database, and we'll see that here in a second. And gave it a much more Windows-friendly approach. SWMM 4 was very much a DOS. You'd run it, text files and things like that, and you would run it. Obviously, there were a lot of third-party developers that, with the XTran and things like that, came forward. I did a lot of my work, recently with XP SWMM. And XP SWMM is SWMM 4 still, right? But it's a wrapper around that. But that's the kind of the history. Today, we're at SWMM 5.2. It's 2024, right? So it's been 20 years with this SWMM format. Yep, wrong button, wrong way. Let's go. So let's just talk a little bit and personalize this journey, right? When I started to learn as an engineer, I learned with the planimeter, right? Learning how to digitize areas. was not very good at the plane emitter, right? I ultimately was never comfortable with that process just because, well, I was never comfortable with it. You know, making copies of nomographs and marking them up was, again, also something that I was never comfortable with, because I always hated not being able to reproduce something or having to get a clean copy and go from there. I saw Autodesk and AutoCAD a long time ago in junior high, and that solar system kind of hooked me. So I looked at ways of automating and jumping into the CAD environment, right? I always sought to have an answer to that problem and make it repeatable. And technology really was beginning to accelerate. Now, my environmental engineering professor pretty much said, make a photocopy of the watershed, cut it out on the dotted line, divide it by the unit weight of paper, right, to get the area, with this, with the scaling. And I, like, it's not very repeatable, right? I would hate to cut up the hydraulic atlas maps and things like that. So it kind of ran a bit contrary to what I had expected, right? So we those tools, they kind of grew with us, right, over time to get better and better, right? And our tools have gotten, and the data that we can collect today, is pretty rich, right? We can pull LiDAR information for terrain, spatial data, right? People are much more apt to have GIS databases of our sewer systems today than they were even 10 years ago. But it helps us more with the physical and estimations of how do we need to build our models, right? If we go back some simple abstractions, we can actually do much more physical-based modeling now with GIS. It kind of hurts a bit, right? I didn't actually ever use punch cards. I did use LearnHec2, which was text-based punch cards. I've never dropped the text file, right? But I worked with engineers who said, yes, I've dropped my punch cards. I'd hate to put them all back together, right? SWM4 text file. I found this, and I struggled with building SWM models with text files, right? It not very friendly, not very, I don't know. It just didn't work for me. Ultimately, in 2004, SWM put a GUI to it, made it available for free, right? SWM 5, this is an image of SWM 5.1, graphical buttons, very Windows 3.1 like, but hey, it's there. You can actually add things. It's very graphical, so you can see what you are selecting, what that catchment is, and go from there. So building SWM4 files were pretty daunting, right? And that's one of the reasons why with XP Swim, you really never understood that it was SWM4. So the visual nature is always great. The difficulty always then became, how do you take the real world that we live in today, whether it is in GIS or in CAD, and get it into some kind of number, right? So the SWM runoff is really a estimation of rectangles. So we have an impervious area. We have a width associated with it, and it has an area. I'm pretty sure most of us, you put 5 or 4 of us in a room with a watershed, but, we'll end up with like 5 potential answers as to what the width of that watershed is and what the impervious. It's something that there's a bit of abstraction going on, and somebody will at least change their mind and suggest something other than what they originally suggested. So converting reality to a number, sometimes, but it's always something that when we calibrate a model, this is one of the values that we would typically adjust and manipulate. So this lump parameter, always, again, just gives us that final discharge at that outlet point, right? One of the things that I think TUFLOW does really well. But that GUI puts up another text file, right? The text file is kind of a little hidden. It's an INP file. And these are some of the sections, right? Subcatchment, subareas, infiltration. It's a space delimited file, which makes it a little difficult to put, my space subcatchment as a name, right? But it's a text file. There's a GUI associated with it. A lot easier is the hydraulics end of it, right? These are the physical nature, the physical gray elements, primarily, your junctions, your structures, your pipes. Maybe this is a transect with a channel in there. But these are the easy things. We can all pretty much agree on what these values all represent. So this is the easier element to put together the underground system, and code that ultimately into an INP file format. But to do that, right, we need tools to do this, right? How do we take reality or the data that we've captured from reality and get this into, SWM 5, right? And that's really where GIS can come in. So with that, Rusty, I'll turn it over to you. No.
All right. Hopefully you see my screen. Thanks, Matt. Appreciated that introduction, and really sets the stage for what we wanted to do with what we've been working on with these SWM tools. So first off, what was our motivation? Well, TUFLOW added SWM as an alternative to the 1D engine. TUFLOW, the 1D, which we call S3, has a rich GIS integration, and we wanted to be able to provide kind of that same functionality for our SWM users. And so we created some tools within the TUFLOW QGIS plugin to be able to bring over your SWM data and work with it inside of GIS. So why would we want to put the SWM data in GIS? I mentioned the option of being able to, be comparable to what we've done before, but more than that, I think that this graphic on the right kind of describes when I think about GIS, right? It's got all different kinds of data, that we see around the outside, kind of in that inner ring. It kind of highlights that, some of the different storage mechanisms. It can be in the cloud, it can be on your desktop, it's layers, right? So there's GIS can incorporate so much stuff, and it's stuff that people are using, right? So, as we break it down, it gives us better mapping, really easy to share online. Engineers are using it all the time, so they're familiar with it. There's both free and paid options out there. And inherently, GIS is very scriptable. All the systems have integrations for scripting engines to be able to do stuff. And that's a real key as well. Being able to script and edit things and as you go. So we'll kind of break this down a little bit. One of the things that's really nice is once you start looking at the symbology, you can, look at it all different ways, right? This way we're looking at, what are the different kinds of links, and they're colored by the links. We can also color it by the width, right? So the colors there, darker colors are a wider conduit. We can, instead of coloring, we can actually make the width of the lines based on the widths. And, we're making pretty pictures and looking at different things that way, but also this can help us to look at your data and make sure that it looks right? That if you had a really skinny pipe in the middle of all those thick ones, you'd wonder what was going on, right? And we can even take it a stretch further and look at elevations, right? So this is looking at interpolated elevation, so the color gradient can change along a conduit. And so we kind of zoomed out a little bit to kind of give the full picture there. But yeah, so these are all different ways, and it's just a handful of the possibilities. It's amazing just all the different things that you can do in GIS. And so that was one of the reasons we wanted to bring it over. It was the visualization part, but also the analysis part and the scripting and all those other things. And so we decided to add these tools into our TUFLOW QGIS plugin. So QGIS is a free and open source GIS application, and the TUFLOW plugin you can get from the plugin repository. It's free. It has tools for working with TUFLOW models, both the 2D and the 1D, and now it has tools for working with SWM models, SWM data. And you can download it and use it with your SWM. We'll show some of how we do some of that. And you can do that even if you're not using TUFLOW, right? You can use the TUFLOW plugin, work with your SWM data, and export it back out and run it in SWM or whatever other system you want to work in. So when we decided, taking a little bit of a step back, we decided we wanted the SWM data inside of GIS, and we wanted to talk about, well, how do we want to store it in GIS? How do we want to work with it? And so we decided to store the data in GeoPackage files. So GeoPackage files, the reasons that we decided on those is they're based on an SQLite database. It's an open, non-proprietary format. You can have multiple layers in a file. It works both with QGIS and ArcGIS, and everything works really fast. It does not have a lot of the limitations that you have for shapefiles. Shapefiles, you have a lot of limits on the size of your columns and names of columns, a lot of things. All of this doesn't have it. We can have different kinds of data, right? We can have data that's spatially there, like some of those. And we can also have tables like this table is just the options table, right, mapped across. And it doesn't have any spatial component, but it can fit inside of that SQLite based data. And you can still bring it into GIS and look at it as a table, even though it doesn't belong spatially anywhere. And so what tools do we have? Well, the key ones are being able to create the GeoPackage files, add sections, convert to and from the SWMIMP files. We have some other tools. We'll talk about some integrity tools to help do some QA/QC on your model data, some model data. So we have some model editing tools and then some conversion tools in there. So those are kind of the categories, kind of the full list there on the right, but a lot of them are ones that you may not need to do. So we'll go over we'll show what this looks like in real life and for some of these key pieces, working with swim data, right? So first, we might want to be able to create an empty swim GeoPackage so we can start either converting data or creating data inside of it. All right, so this looks like this. We go over to the TUFLOW processing tools. We find the swim section, and there's a GeoPackage create tool in there. And we have to give it a coordinate system. And then we tell it, which sections do we want, right? And that showed the file. It's a whole bunch of text-based file, a lot of tables. And so we're just picking those that we want. I'm just going to leave this file scratch, that GeoPackage. We run the tool, and it's going to create this GeoPackage file. So if we go look in the folder, there it is. And we can bring that file and drag it into the application. QGIS recognizes it as a GeoPackage and asks for which layers you want to add. And we'll just pick all of them, right? So these are all these tables. They're all blank, but they have the attributes set up for the data that's going to be required to work with SWM, right? So that's just the junctions table. And we can edit, right? We can digitize nodes and put the data in there. Just, as an example, putting in some information there and creating a node, right? And you can save it, right? So yeah, it's one way to get the data. Once you've got those sections created, you can convert from other GIS data, map it across. You'd have to do kind of a translation there and match up the fields, but you could do that and fill it in. Other thing you might want to be able to do, or you might do, is you might already have an IMP file that you created or was given to you, and you might want to import that and be able to look at it in GIS. So that's what it looks like here. For that, you just, we can look at the file again. As Matt showed, it's just a real text-based file. I search on the brackets, we can kind of see some of the ones in this file, right? Junctions and outfalls, storage nodes, conduits, right? It's pretty standard SWM components. And we go to with the plugin loaded, go to bring that into QGIS, we just drag it in, and then we can tell it it's going to recognize that file type. We have to tell it what coordinate system it belongs to, because that's not in the SWM file. And it'll default to the output file name matching the IMP file. And then it's going to ask us which layers to load. And there we load our files. And now we can go and style it. So, and I always like the blue arrow. So just what I like to do, right? We look at the attribute tables, right? This same attributes that we saw before, but now we've got information assigned to them. Now that it's in GIS, we can edit it, we can work with it, we can create pretty maps and all those things that we need to do. Use it in other analysis, things like that. Right? So once you've got it there, one of the things you might want to do is make some changes, right? Often we don't want to change. You don't want to change the file that you have. Often you want to create a new file. So, you can always go back and then modify and export, right? So we'll go through what that looks like. Well, we can right click on a layer inside there, and we can tell it we're going to increment the GeoPackage, meaning we're going to give it a new version. And so it's going to default the version, right? We're on 001. It's going to default it to 002. We're going to unload the current layers. Go ahead and click OK. And that's going to unload everything and reload that incremented file, right? And so we lost our Symbology. I'll go put that back. And we can go look and see now we used to have a 1, and now we also have the 002 GeoPackage, right? So we can go look at it and say maybe we want to change one of the conduits there. It had the wrong roughness in there. So we're going to go and change that. Probably not a big deal in the grand scheme of things, but, want to fix it. So we save it, stop editing, and now what we want to do is export that to an IMP file. And so we'll go and we right-click again, go down to the TUFLOW, and there's an option to export IMP. It's going to default the file name, and it's going to run. We don't see any errors there. So we hit close, and we can go into that folder, and we can see now, along with the 001s, there's a 002 IMP file that was created from that GeoPackage And if we open up, look at it, it's going to look a lot like the one that we had before, with the one change to the conduits, which we won't show. But yeah, once we've got that data into GIS, there's just a lot of options for modifying it, editing it, viewing it, different kinds of analysis that we can do. And then when we're done, we can export that file back out. It's again an INP file that's supported by SWM. You can go pull that into SWM and run it. So just like you would normally do. Just you have this new option of being able to do it inside of GIS. So the other piece that we have, or one of the other pieces that we have in these tools, we call these 1D integrity tools. These are ways to look at the model, help make sure it makes sense, that it matches with your DEM data that you've got, that there's nothing surprising in the network, things like that. So one of the tools is called a continuity check, right? So we're going to check things like, does the flow area make sense? Do we have a really big change? Do the inverts, do they make sense? Do we have negative inverts or inverts that have uphill sections, things like that? We also check the ground cover against the DEM. And so, we bring in this 1D integrity tool, part of the TUFLOW plugin. We identify the layers that we're going to use, and we go ahead, click run, and there we've got all the different places that have not met our requirements for our things. We turn on the labels and see some of those are because of insufficient cover, some of them are the flow area decreases, all these things that we flagged. And being able to see those on the map is pretty handy because you can see hotspots, right? You might find you have some areas that have poorer data representations than others, or missing data that gets flagged by this tool. That can help you define, areas that you might want to spend a little bit more time trying to improve the data. So a similar tool, flow trace tool. There's a few others, but this is similar. It checks some of the same things, but we're also able to see things in kind of a section plot. What they call long plots here. And so we're going to turn on the checks that we want to do. And we're going to select, in this case, one of the differences, we're going to select a pipe that we're going to start from, and it's going to show us all the pipes that are connected to that one. And being able to see that is useful because you might see pipes that are connected that shouldn't be, or pipes that should be connected and aren't. That'll let you know that your network's not complete if you have things like that, right? But you can bring it in, you can cycle through, and these are different kind of paths through the network, and you can label it. And when you click on that select path in Workspace, it's going to show you which path it is exactly, right? And so we can zoom to it, and we can see, that it's pretty clear there was somebody made a mistake when they entered the data, missed a decimal place, and they have a pipe in there that's not the right size for the ones around it, and it's likely a data entry error there. So being able to see the data like this helps you to flag potential problems and see where things might be problematic. So yeah, these are just a couple of the examples of the integrity tools. There's a couple others, but these ones are really helpful to be able to identify potential issues, right? And so what we talked about so far is on the GIS tools, being able to bring in a GeoPackage, an IMP file, convert it to a GeoPackage, work with that GeoPackage in all the ways that you would in GIS, and do whatever analysis and visualization you want to do there. That's all part of the free TUFLOW plugin. You can use that. You can do it and use it with SWM by itself. We want to talk a little bit about SWM coupled with TUFLOW, right? The whole reason that we created those tools was to be able to have those in place for people that are looking to couple TUFLOW with SWM. So talk a little bit about what the value added is of linking SWM with TUFLOW and using it that way. That becomes the commercial product that when you get purchase a TUFLOW license to use this part. All the stuff before, you don't need a license for, and you can use by itself. So TUFLOW has a long history of linking to different 1D models, starting in 1990, linked to S3, which sometimes we'll call the TUFLOW 1D engine. Later in 2006, linked to XPSWM. So that was actually linking to SWM. Also the same year, Flood Modeler, which at the time was called ISIS. And then later, 2012, linked through 12D. All of these are different kind of systems and interfaces that have kind of different tools that are added along with these 1D models and 1D engines that are linked to the 2D. And now this year we added the TUFLOW SWM directly. And we did that so that people could be able to use the GIS tools that they're familiar with and link directly to SWM. And so, so we wanted to add SWM for a variety of reasons to TUFLOW. We wanted users to be able to leverage existing models that they have in SWM and SWM-based systems. A lot of users are familiar with SWM. They understand how the models should be set up and the settings and options that are there. It's embedded in a lot of different applications, right? Lots of different engines and platforms that incorporated it. And so there's a lot of different editing and visualization tools out there that you can leverage in addition to the ones that we talked about today. And TUFLOW SWM, when it runs, it uses the standard EPA SWMM 5 IMP files. So you can generate those through the EPA SWMM GUI or these TUFLOW SWM tools or anything else. It's just a real standard EPA SWMM 5 IMP file that we're linking in there. So why would you want to link TUFLOW and SWM instead of just running SWM on its own or some other system? Well, first of all, you get the advantage of having a 1D, 2D model, right? So the 2D solver, or the TUFLOW 2D solver, it's not just any solver. This is, state-of-the-art solver. It's got GPU acceleration, subgrid sampling, quad tree grid refinement. So it's not just linking to just a 2D solver. It's to a really, really state-of-the-art 2D solver that you're linking to and being able to take advantage of that overland flow component. We link the two with kind of these HEC 22 style inlets based on the Federal Highways Administration manual. We'll talk a little bit about that. You can use rain on grid or SWM hydrology. So with rain on grid, you're just dumping the water straight on the 2D domain. It finds its way to the inlets. The inlets will convey the water into the network, and it'll trace it through the network or overland depending on, capacities and how overloaded they get, right? So there's a lot of benefits of having a 1D, 2D model where you're actually able to capture in 2D what's happening above ground. The other thing is you can use scenarios and events. TUFLOW does a really good job with handling scenarios and events, be able to look at a lot of different alternatives without having to duplicate your base common input data. By not having to duplicate that common data, you can, something changes, updates, you can, you get new DEM data, you can update that and rerun your alternatives really easily without having to change it in multiple places. It's really slick. Also has this boundary condition database where you kind of store all of your curves, and it's pretty flexible in how they're stored. It's intended to be, you kind of have your curves in the format that you like, usually like a CSV file format. We also support HEC DSS files and some things. And anyway, you have these curves in your boundary condition database, and you can plug those in and use them. And with TUFLOW linked with SWM, you can actually even SWM data. If you have an inflow that's assigned to a node coming to your 1D, you can actually connect that inflow to the TUFLOW boundary condition database, so that as your different events change, it'll automatically update, and you don't have to change your SWM model to change that inflow or that rating curve, just whatever it needs to be. And then third thing would be these GeoPackage time series results. Just like we did on the input side, on the output side, if we're running a combined TUFLOW SWM model, we dump the results into a GeoPackage file that you can go back and visualize inside of the QGIS, and especially with the TUFLOW plugin. And we'll show you what that looks like as well. So the 1D, 2D linking, we mentioned that, especially doing like a rain on grid, you're going to have water coming down overland. It gets into your streets, hits these inlets, and you have to decide, how much water is coming in the domain. And we're using modified EPA SWM code to kind of figure out that capture using information from the 2D model. And so, we're able to, handle all the different cases on SAG or on grade inlets. So on grade inlets, the water's shooting down and it can hit the inlet, and some of it might get captured and some of it might bypass. This picture is actually, when I was on spring break trip with my family. My wife was driving and we got caught in a big rainstorm, and I was working on all this stuff. And so I was pretty excited to see this, on grade inlet, the flow bypassing, because the water was coming a little pretty high. My wife she didn't think it was as interesting as I thought it was. She was a little more worried about being caught in this rainstorm, but it was good. It was good and interesting to see it in the real world. So we can connect those two, but how well does it work? So I did some testing. I wanted to make sure that the overland, representing the overland in a 2D model was going to capture and represent the right inflow into the 1D model. So we set up some of these test cases that are in the HEC 22 manual, and put them in and set them up and see how it would work with the TUFLOW SWM. And the results came out really good. They just matched amazingly perfect. I was a little worried they'd come out a little different. One's kind of an empirical basis, one's in a fully 2D model, turbulence and everything, but you set up the problems the same and you get the same results. So, depending on the results, your input data, that you've got to have a good DM and stuff to capture these things well. But if you've got good input data, you can be really confident in the results. And the subgrid sampling, we want time to, basically every cell kind of looks like a cross section, and the storage is represented by the underlying DM. I think that really helps when you're talking about these inlet capture. So we run the model, your combined 1D, 2D model, and you bring it back in, and what is it you can look at? So this is an example of the kinds of things that you can see. And there's a lot going on. You got the 2D model outputs, the depths going overland, right? As we kind of march through this flood, you can see all the different things that are happening there. Up in the kind of the top right corner, you can see this plot. That's a discharge plot. And there's kind of right in the center, bottom center of the map, you see a red polygon, and that polygon is kind of telling us where those plots are taking place. So that's both the cross-section view that we see on the lower right and the discharge in the upper right all come from kind of that piece, right? So we can plot time series and section plots through the 1D at the same time we're viewing the overland from the 2D. And then we're coloring those pipes based on the values. So you can see the colors change as we go through the hydrograph, and those colors are changing based on the discharge, right? So we can do the symbology, all the kinds of symbology things that we would do. We can do those with the results and color the results both on the nodes and the lines to help us to demonstrate the model results. So that's another kind of value-added piece of being able to run with TUFLOW SWM. And all of that's back in your GIS. It's in open formats. You can take that and go somewhere else with it. Somebody who doesn't have TUFLOW can look at them and work with them because it's all just those generic file formats at that point. And you can actually bring those results also into ArcGIS. Do a lot of the same kinds of things over there in terms of coloring or using symbology on the results. For some of the animations and stuff, I had better luck if I converted those GeoPackages and the 2D outputs into Esri formats. But once I did that, I was able to do a lot of the same things, create plots, animations, all those kinds of things you can do over ArcGIS as well. So that was just a highlight, in addition to just the free TUFLOW SWM plugin tools that you can use, just a little introduction to TUFLOW connected with SWM. And if you want to learn more, we have tutorials on the website. You can use those without a license. They're set up to where you can go through and run those. You can look at the documentation, and we have a link there to our past webinars. So I'd just like to thank everyone for joining and being on, and for the Australian Water School for putting on such a great system and having this in place. It's just really good. So I'll leave it there and we can go to question and answers.
Rusty, thanks very much. And Matthew as well. You guys capture the holy grail of modelling in my mind, and that is how to create the real world in a model. I mean, Chris, it's got to be one of the hardest things in the world to do, I reckon. But what we're going to do now is Chris is going to moderate and mediate for a Q&A session for at least 10 minutes. We've got about 10 minutes left. So right over to you, Chris. Thanks very much.
Thanks, Trevor. Also, thank you, Rusty and Matt. That was a really great presentation. The Q&A line has been hot, so I've taken down a number of the most upvoted questions, and I'll just ask those to Rusty and Matt, even though they may have already been answered. This was asked twice by two separate people. We note that the plugin is currently built in QGIS. Is there future plans to create something similar in ArcGIS Pro?
Yeah, that's a good question. The way it was architected, there's really kind of a piece in there that's kind of agnostic, right? You can pull it out and run it from Python without QGIS. And so we would need to it's something that we've talked about a lot, and we need to just kind of add, hopefully, a relatively thin layer on top to make that work. But I can't say specifically when that would necessarily happen. But that's I think what would it take.
Okay. Does the tool itself, does it convert all SWM data, or is there some things missing currently? In particular, someone mentioned lid information, so low impact development details or low impact design details, depending where you are in the world. Does it cover all of those features?
Yeah, that's a good question. And everything is supported right now, with the exception of the pollutants on the water quality side and kind of the loadings of those and stuff. So that's something that I hope to add, but right now it's just focused on the conveyance pieces.
Okay.
But lids do come through, so they kind of map out, right? This, when we switch to a GeoPackage, some of the SWM tools will use these tables where this kind of the same rows will end up with different information. It's kind of and so to map that to GIS, we often kind of make really wide tables to have individual kind of unique information. And so, especially with lids, it can be a little daunting to look at them in the GIS, but they do convert over and they come in. They might be easier to kind of edit in the EPA SWMM GUI and create them over there and then load them up into your GIS, but they do map across. You can work with them over there and bring them back in. But they will look a little different because it's just of the wide format.
There's been a number of questions about software conversions. Can, for example, PC SWM or XP SWM models be converted across to TUFLOW?
Yeah, so, and that's going to depend on from a little bit system to system. PC SWM, you can export the SWM IMP file and work with it, bring it straight in. It also has some 2D, some of its own setups for kind of the larger models. Some of those that'll have shape files and things, you kind of have to manually kind of transfer those, map those across. With XP SWM, there is a tool that you can export the XP SWM called an XPX format, and we can convert that over, and along with the TUFLOW XP SWM for running TUFLOW underneath. So you take the TUFLOW models that it creates and the XPX file, and we can recreate the TUFLOW and SWM.
Okay, yes. Yeah, so XP SWM, it creates a TUFLOW model basically, isn't it? So you take that and run a tool to post-process the XPX files, and that brings everything in together.
Yeah. It kind of it merges those two together to create kind of a new clean slate. So.
Okay, a couple of people must be avid estuary users, and they've asked about the hybrid coupling of estuary with SWM, and in particular, if you can use estuary to model the inlets, like the pit, what we call pit inlets in TUFLOW language, instead of using the inbuilt inlet features of SWM, which would subsequently require, say, street input information. Can that sort of hybrid approach be used, or do you have to model the whole pipe network, including the inlets, in a SWM form?
So that you can use both estuary and SWM together. I hadn't thought about using it on that same level. Now, SWM inlets, they have those ones that are shape defined. You can also have curves, so you can use kind of the same kind of setup to estuary where it's a relationship for head and flow. You can also do approach flow, relationship between approach flow and inflows, and so they actually map pretty well across if you use the curve based things. So I'd probably recommend trying that first, but you can use estuary and SWM together. I was thinking more of in the cases of things like the estuary has some ways to map the 2D. So you might do like in cross-section based things in estuary and all your pipes and swim, for example. But I probably wouldn't try to mix just on the pits themselves.
Yeah, okay. And in terms of licensing, is this a different license? If you have a TUFLOW license, do you have to buy some special module to tap into the SWM component of TUFLOW or not?
It's just part of the TUFLOW license. So.
Excellent. Fine. Do you actually have to even do anything with TUFLOW to use this tool? Like, can you use it independent of TUFLOW altogether?
So on the GIS side, all the stuff we talked about at the beginning, yeah, you can use that and let us know how it works for you, without ever touching TUFLOW at all, right? You can bring in your data from, that you've created, or create data, write it out, go run it in the EPA GUI, right? All that you can do for free. You don't have to touch TUFLOW. You don't have to have a license. You don't need any of that. And you're welcome to go do that. It's only if you want some of those added value features that we talked about on that second part, or that last part, where you would need to think about a license and getting advantages of the 1D, 2D coupling.
Well, there's a question that's been left unanswered because I didn't quite understand the terminology, but maybe you might. Does TUFLOW SWM support linear drainage, i.e. graded channel modeling? I'm not sure what graded channels means. Does that term mean anything to you, Rusty? Or Matt?
More like think of those as being like the drainage ditches, trapezoidal shapes. And yeah, it does support trapezoidal shapes. And you can even do cross-section based in there. Now, we don't have any nice tools. That's the one piece that we don't. We can bring those in back and forth, and you can look at the data, but it doesn't show a really nice view of those cross-section based channels. That's one of the, this is kind of 1.0 of these tools, and we hope to have more things later. Maybe that would be one of them, but you can, it is supported, and they can go back and forth, but they don't have a lot of extra tools for working with some of that.
And if someone did have feedback or questions, they just email support@tuflow.com.
Yep.
The best avenue for that, is it? Yeah.
Is the best way to let us know if you have suggestions or things that you'd like to see or whatever. Just drop us a line there.
Okay, we're right on the hour now, so I might close out there. I said there's a couple more questions left unanswered. We'll actually answer those after the event and post them along with the recording on the AWS website. So we will answer all questions, even if we haven't discussed them here now.
That sounds great. Thanks so much, Chris, Rusty, Matthew. Well, that will be it for today. It's just awesome. There's a recording that will be emailed to you. We'll upload it to our website and YouTube channel. As a live attendee, you'll get a certificate of attendance coming to you within 2 business days. That'll be for your professional development. And also, as you close off, there'll be a short 1-minute survey automatically pop up. We'd love to hear from you. It will be so useful. Well, I just can't get over the incredible amount of experience coming to you from the USA, WSDAT, Idaho, and Florida. Thanks, Matthew and Rusty. It's just brilliant to have you on board. And for the TUFLOW team at Chris, Pavlina, and Phil, thanks so much for your incredible efforts here. It's an outstanding team. And behind the scenes, of course, Renee, Anushri, and Joel. So what a way to go. You can see on the screen now the things coming up, how to benchmark your hydraulic model. I read it all. You can go through that. There's so much going on here in the rest of 2024 here at Australian Water School. But thanks again to everyone. I think we've covered everything. Let me know if not, but I reckon we'll call it a day there. It's been such a joy to work with you all, and I look forward to seeing you again sometime. Thanks everyone for joining us and for asking questions, making the discussion great. Please join us again for future free webinars at the Australian Water School. That would be great. See you soon. Bye for now.